Okay, here's day 2 of finding points of inflection. Take this slowly. This is another pretty simple example. So to find the possible points of inflection, we have to find the second derivative. So here goes. The first derivative is this. And the second derivative is this. So second derivative. So now we have to find the possible points of inflection where the second derivative equals 0. So we set it equal to 0 and factor, which gives us possible points of inflection at x equals 0 and x equals 1. So now we make our second derivative chart. 0 and 1. We find the second derivative at a point in each of these intervals. So here I'm going to try -1. Here I'm going to go with 1/2. And the last interval I'm going to go with 2. If you plug -1 into this second derivative, you'll get a negative times a negative, which is positive, which means concave up on this interval, -infinity to 0. The second interval, if you plug in 1/2 to the second derivative, you'll get a positive times a negative, which is negative, which means concave down on this interval, which is 0 to 1. And the last interval, we're going to plug in 2 to the second derivative, which gives us a positive times a positive, which is positive, which means we're concave up on that interval, which is 1 to infinity. So there's our concavity. So now we can conclude which of these possible points of inflection are actual points of inflection. And because the concavity changed at each of these points of inflection, they become actual points of inflection. So we do have points of inflection at 0, comma, and you plug the 0 into this original function to get the y-coordinate, and that's obviously going to be 0. And we also have a point of inflection at 1. When you plug in 1 to this function, you get 1/12 minus 1/6 plus 1, which turns out to be 11/12, or 0.91, something like that. So that's it. You can look at a graphing calculator to check to see if those look like points of inflection, which I have done for you right here. So it looks like this graph is concave up from here to about here, which is 0. So that's the first point of inflection. And then after that, it goes to concave down. So it dips a little this way, you can see, at this point, which is 1, 11/12. And then it goes back to concave up afterwards. So that kind of confirms what we've just done. So I'm going to leave you with 3 more kind of simple example problems, and we'll move on from there tomorrow.